Good morning, good afternoon, good evening, all of you guys, depending on where you are. Thank you for attending this webinar. Really appreciate the opportunity to present ARM's point of view in terms of what smart lighting means to us and what the linchpin of smart lighting is, which is really securing it first. So let me get started. So first of all, when we are speaking to the industry, speaking to your customers, we are coming to the realization that businesses are increasingly focused on making their assets, which are really the people and the things inside the building, more productive, secure, better utilized, comfortable, etc. And that comes from the often quoted 330-300 rule, where the higher value use cases are really the use cases that make people happy and productive and safe and comfortable. And what we have noticed and why I'm really excited about lighting is that lighting becomes a very convenient backbone for all the insights that you need to get from a building. Because lighting is ubiquitous, it's everywhere from the parking garage to the IT closet room. And because, as Maury mentioned, the digitization of the SSL lighting has really helped in getting the right kind of data from lighting, controlling the lights at a very granular level, and they become very easy conduits for all the information that the building owner and operator needs from the building. And as people are spending 90% of their time indoors, and 90% of the building's operating costs are really are the lifetime costs of energy and operations of the building, getting these insights becomes very important and critical for not only the management of real estate, but even things like employee retention, employee attraction, improving the asset value of the building, improving the security and safety of the building, as well as improving the convenience of the people in the building, everything from asset visibility to wayfinding, for example. So we are seeing all these use cases, and our point of view is that you can make buildings more sustainable and responsive to internal and external stimuli and healthy, safe, secure, etc. through intelligence, and this intelligence comes from IoT. And in fact, ARM has been the architecture of choice for the Internet of Things writ large. Everything from advanced sensors to boards to kickstart your development. As Maury mentioned, if you have a smartphone, there is a 98% chance that it has ARM technology in it. And now what we are doing is bridging our strength and legacy, 25-year legacy, in building these technologies and empowering all the future technologies with our hardware solutions. We are marrying them with some of the software and services that we are developing around deploying and implementing smart lighting solutions. So that's what I'll talk about today. And ARM is pervasive across the smart building architecture, as I mentioned, especially so in areas where you have miniature low power sensors. That has been ARM's strength for years. And hence they become the architecture of choice for miniature sensors and thermostats and lightings and sensors and controllers. And I'm sure many of you have worked with ARM-based processors. More than 3 billion ARM-based sensors are out in the market. More than 100 billion ARM-based chips, as you saw in the previous slide, have already been shipped. But what has happened is, despite all those benefits of lighting and all the benefits of Internet of Things, smart lighting itself has not seen an uptick as much as we had all hoped for a few years ago. And one of the reasons that our customers and customers have articulated to us time and again is one of the concerns has been security. So today's webinar is really focused on security as a way of unlocking the building's potential, IoT potential that has not been unlocked before. Speaking of needs, when we speak to our customers, and especially the lighting industry, we keep hearing a very similar set of requirements from the lighting industry. A transparent connectivity abstraction that you can build on so that you as a IoT developer, a smart lighting developer, only needs to focus on creating an application in the cloud and maybe creating an application on the device if you're an embedded engineer. But everything in between, any of the connectivity protocols, whether they are IP-based or non-IP-based, whether you need a gateway or not, whether your requirement is for a cloud solution or on-prem, regardless of whether you need a connectivity or you need some access for maintenance and commissioning when there is no connectivity, all those things should typically be taken care of. They should be things that are under the hood, if you will. And so one of the requirements we have received often is that people are asking for a transparent connectivity abstraction so that you can build your applications regardless of the protocol. People have asked for flexible on-premise and hybrid offerings. They have requested for technician access during commissioning, especially when there is no internet connectivity. I'm sure all of you have a number of interesting stories to tell about your favorite stories about commissioning, and we hear that as one of the pain points time and again. Lighting OEMs are also interested in not having a vendor lock-in, whether it's with respect to the cloud, whether it's respect to the technology stack or the hardware device itself. And they are, of course, first and foremost interested in an extremely secure lighting solution, which is really the crux of today's topic. So let's do that. ARM's point of view has been that security starts at home first. It starts at the foundation level. And just like you wouldn't build your house on a shaking foundation, we believe that a trusted, secure foundation for the Internet of Things devices that are going into the buildings, and especially in lighting, is extremely critical. Because a single vulnerability that arises from the smallest of those devices can create havoc in terms of bringing down anything from bringing down the grid or sending spam messages across the network and bringing down the business network. And what we have found out is securing that critical foundation becomes important because what you as a lighting vendor or a lighting developer or a smart lighting engineer wants to focus on or should be focused on are things that you are able to monetize, are able to derive value from your customers, the things that are at the top. You want to build those really nice applications for your customers that help them with office security or wayfinding or asset visibility or improve their building automation. Everything under the hood, whether it be hardware at the bottommost layer, hardware meaning microcontrollers or radios, or the connectivity stacks in terms of different protocols and managing different types of connectivities across IP and non-IP layers, whether it's security, is it communication security or a secure boot or secure software updates over the air, all those things should typically be taken care of, and they should not only be taken care of, they should be the foundation has to be made secure from the chip to the communication all the way to the cloud. And just having the ingredients is not enough. Oftentimes, companies have different blocks. Sometimes they build things on their own. Sometimes they get it from an open source GitHub. Sometimes they license it from a company. And you get a variety of different building blocks from a secure factory tool to a threat analysis model or a mechanism to do firmware updates over the air. But just those ingredients are not enough. Security has to be thought of at the system level right from the beginning. And ARM helps our customers do that through a very thought-through, rigorous, comprehensive security mechanism, starting from the smallest of crypto libraries inside the chip to a secure communication channel that is encrypted. And the industry is in dire need for such solutions. Poorly secured ports and devices cause vulnerabilities that are readily exploited by hackers, as you know, and even governments. So ARM, in fact, took a proactive approach last year. Our CEO published this security manifesto late fall last year, which is our social contract with all our customers, where we claim that security has to be built from ground up, from the smallest of the chips. And what that does is there is no single point of ownership. It's really something where we have launched and open sourced a architecture called platform security architecture that a number of companies from chip vendors to OEMs have endorsed. And really it's not something that one company can do alone. It's the entire ecosystem that has to come together and is coming together behind this platform security architecture. So first and foremost, platform security architecture. This was announced late last year, and we have in fact made a number of advances since we have actually created threat modeling and security analysis documents, also called plain English language documents for these number of assets. I think there's a water meter, webcam, and asset tag already on the web, which comes equipped with firmware and firmware reference codes. And we are now working with the lighting industry to develop something similar for lighting. But what is platform security architecture? It's really a recipe, if you like, that can work on any of the processors, the smallest of constrained devices. What we did is we first started with our homework. We did a rigorous analysis with security consultants and looked at a number of IoT devices. We looked at the assets that needed protecting. We looked at threat vectors that, different types of threats that could be cause for vulnerabilities, and I will talk about that in a second. The attack surfaces that need to be protected, and came up with different threat profiles, and as well as then the recommended architecture for hardware and firmware. And based on that analysis, we came up with, or rather those analysis boiled down to 4 principles that we think are the 4 pillars of platform security architecture. We need an immutable device identity that helps with integrity, and that identity can be inside the chip using real true random number generators and crypto libraries inside the chip. You need a trusted boot sequence that builds that integrity and develops it, because every time the moment the device wakes up, a smart lighting sensor or controller wakes up, it needs to access a secure area from where it can get the rest of the boot code and operating system. We need, over the life cycle of the device, we need secure updates over the air, and we'll talk about that as well. And finally, we need crypto-based authentication. We are strong believers of certificates that allow much stronger level of security than just encryption. And we feel the smart lighting industry can be and is being aligned to the platform security architecture as well. We are, as I mentioned, we are working with some companies around building these threat models and security architectures. But really, everything from the immutable device identity that goes into the sensor or the microcontroller inside your luminaire, to the trusted boot sequence, to the secure over-the-air updates, go beyond pure encryption. Your communication channel is encrypted through TLS, for example. All the firmware updates are done very specifically and very consciously through a very thought-through update program with manifests and certificates. So those kind of things are important, and we'll touch upon each of these topics a little bit through the webinar. But as I mentioned, this entire security of smart lighting has to be thought through at a system level, and all of these elements are just spokes in the wheel. All of them are needed, and none of them are optional. This is just a picture that depicts what can be done in a smart lighting industry, smart lighting topology rather, where the principles of platform security architecture can be applied, and the secure processing environment could be separated from the non-secure processing environment, which is most of the real-time operating system and applications. And the only way to get to the secure environment is through hardware mechanism like an interrupt, and very few things, including the secrets like your manufacturer identity and your certificates and your manifests and your keys are kept in the secure area. But before we talk further about how to do it, let's spend a minute on what is security, and in fact, how much security do you really need? In the industry, security is used for a wide variety of reasons, everything from hardware blocks to software modules. The way I've depicted here in the picture, I have looked at 4 types. The first type is a communication type, which is really every IoT device has a mechanism for connecting to the cloud, and every time you do that, there is a communication channel that could be exploited by companies. And the common way of getting around this is being encryption, and that takes care of many of these communication channel attacks. The next one is lifecycle issues, and for which you need countermeasures. A device changes hands many times as it goes from the factory to the user's ongoing operations to end of life, and we need to somehow protect the integrity of the device, and there's a way to do that. We'll talk about a few mechanisms in this webinar. For example, a common attack is to downgrade the code in the device to a known buggy code or a version that had a fault in order to extract the data. And such anti-rollback mechanisms could be built in, or rather be built into these countermeasures to protect against the lifecycle attacks. The third one is physical attacks, less so in our sector in smart buildings and lighting, where if the data is really that valuable or your product is that successful, hackers might actually resort to physical means of extracting that data. For example, they could remove the plastic cover of the device and insert probes in the circuit and get access to information that is common to all the devices that are built in that batch, but less common in lighting, I would say. And the last one is software, which probably gets the most press, most published attacks to existing code. There could be a software bug, or there could be a malware. A secure solution needs to specify what sort of attacks it is protecting against, and these are just ways in which we can categorize these attacks. And what this does is the security analysis not only helps you analyze all the threat vectors and surfaces, it also helps you forces the thinking around how much security is really enough. It may not be a security threat if someone steals a temperature reading from a thermostat, for example, but now if someone's able to take charge of thousands of such sensors and then send all kinds of random messages through the network to bring it down, then that becomes an issue. So that is something that is, there are some standards in the industry, but there are also a lot of considerations that have to be made on a use case by use case level, as well as that aligns with your corporate policy around security. So security starts with analysis, as I mentioned. You start with a system description. We look at the assets and threats, look at the security objectives, what the requirements are supposed to achieve, and then come up with a threat modeling and security architecture. Not only is it important to start with analysis and look at the life cycle aspects of security, as well as think about how much security needs to be built in, it's also important to secure all stages of a smart lighting device's life cycle. So for example, the moment a device is built, what kind of mechanisms do you provide in the factory to provision all the secrets and keys into the device and assign an account to the device? So it starts with that. It then goes on to, when the device wakes up, what are the secure mechanisms to bootstrap the device? If the device is going to change ownership, do you have mechanisms like first to claim, commissioning in order to change ownership? Are you thinking of certificate authorities, either third party or your own? And finally, during regular use and end of life, how do you manage secure software updates? And when there is no connectivity, do you have a mechanism to actually do the commissioning and access of devices during the time when there is no connectivity or it's outside your security perimeter? So I'll pause for a second. I think there is a survey. In fact, I think I missed one survey. Apologies for that. But moderator, if you could push the next survey, if I could have 20 seconds of your time to fill out a few options for a question, it would help us get some input from the industry, and we'll display the results shortly. We'll be curious to understand what you have considered in making your smart lighting solution secure. Is the survey on? There are a few options there. There is factory provisioning, which is what I talked about, where you insert the keys and secrets in the factory. There is bootstrapping, which is we'll discuss shortly, where when the device wakes up, it accesses a secret URL and does the handshake of the right credentials and the right certificates. First to claim, where you might be manufacturing devices, but those devices are then resold and distributed by other third parties, and hence you might need to change accounts. Certificate authority that basically helps with credentialing those devices. Secure firmware updates during the life cycle. You might have different release patches. You might have to take care of some bugs, and when there are times when there is no connectivity during commissioning or recommissioning or retuning, how do you access different devices and how do you authenticate different users? These are just different mechanisms of doing that, and we'll be curious to hear how you have thought about security and which of these are most important to you. All right. Moderator, if you could show the results, I can move on to the next slide. All right. Thank you, everyone. Thanks for filling the survey. This should pop up as a pop-up box when you hit next. So let's go through each of these one by one. So we talked about these different mechanisms. Let's go through each of these mechanisms one by one. So first is the factory provisioning. When you manufacture your devices either in your own factory or have contract manufacturers do that for you, it becomes important for you to make sure that all the things all your secrets, be it your encryption keys or your certificates or your manufacturer UIDs or the secret URL for bootstrapping or any metadata that you might want to insert has been inserted in a physically secure as well as conceptually secure environment where you are able to provision this in the devices. And this is a one-time process, but even after that, during the manufacturing and onboarding, the same credentials could be used for a variety of reasons. Now, you could have different certificates for different reasons. You might have one certificate for bootstrapping, another certificate for firmware updates, third kind of certificate for regular usage, which is fine. But all those things are inserted at the factory floor, which allows for all the future operations on the device to be trusted, because now you have a trust anchor built in that you can rely on for the rest of the life cycle of the device. Bootstrapping of devices enables automatic configuration of secure device connectivity. So in the factory, you have already created the device identity, but you also could add in a bootstrap URL and credentials as per your company policy. And when the device first powers on, it configures the device by connecting to the cloud. So now you can be assured that the right device with the right credentials has been presented to your Bootstrap server, and you are good to use that device for the rest of its life. So then you can load the rest of the operating system, other instructions. You can then put in your different agents and clients into the device as the case may be, and then make it ready and trustworthy for the ongoing operations. First to claim, oftentimes the device, the device always needs to be connected to an owner account, but oftentimes the owner is not known at the time of production. And first to claim is a mechanism where you account for the fact that the device ownership may change, requiring moving it to another account in future. So oftentimes this helps the owner of a device to assign the device to an account after production. This is really a way to transfer future ownerships before the device's end of life. And it's kind of, you need to think of different compromises, for example, compromises between security with multiple options, as well as the logistics of really the supply chain of all your devices and how you intend that device to be distributed and finally deployed at your customer site. The certificate authority is a way for you to, for really a third party to allow an external certificate authority to sign device keys that are configured in the device. There could be a number of certificate authorities that you could use, Global Sign and CFSSL, Cyber Trust, or you can bring your own. But the key here is that the signs that are used during the Bootstrap are something that have been authenticated by a firm that you trust to take care of for your rest of your keys and certificates. Remote software update, one of the most, I guess, sought after, very critical mechanism for security. Replacing cheap devices is of course possible, but oftentimes it's not just the cost of the device that's the issue here. It's the total cost of ownership that needs to be considered. Sometimes the device is just, it's very difficult to access the device physically. It might be in a remote location. There are labor costs, of course. There's a cost of the impact of limited functionality or a shutdown if that's needed. So remote updates soon become much more cost effective when you start thinking of all these different factors. And what's happening today is IoT devices that are getting into the field they kind of start a marathon. Once the device gets deployed, they last for 10, even 20 years. And new use cases and features are constantly being introduced. So you might have to have a mechanism to roll out these new features and add features throughout its operation at regular intervals. There are, of course, bugs. Bugs are a fact of life, and they need to be fixed to prevent malfunctions and damages. Sometimes compromised instances may result with only a fraction of those devices being hacked, and you might have to decommission those devices. And in those instances, there might be a way to target specific firmware updates. Sometimes it's just difficult to access those devices, so things like conditional updates and specific targeting of devices for updates become important. Also, there could be things like fail-safe protection that I mentioned earlier, where in case of power failure, you are able to check the main image of the firmware and ensure that it's not corrupt, and then make sure that a power failure doesn't, quote-unquote, break the device. There are anti-rollback mechanisms, which I also mentioned earlier, where you prevent the installation of potential insecure or incompatible images. So an update will proceed only if the associated firmware manifest has a later version. You can do that through a protected counter, for example. There are ways in which accident protection could be employed through either the manufacturer model or revision or attributes associated with the firmware. But really, when we think of all these things, what we are saying is security is an important cornerstone of smart lighting, which is what is preventing it for all the building's IoT potential to be unlocked. And all these mechanisms that we have talked about so far are ways in which we make the device trustworthy, we ensure a trusted anchor, we ensure that the life cycle operation of the lighting device, smart lighting device is secure. The communication channels in which data is sent to the cloud is secure. And then during the life cycle, all the updates are done in a robust, rigorous, secure way. And all these mechanisms to do that just make that a virtually hack-proof way of doing it. The Cloud Security Architecture Alliance, for example, has said that secure access to devices become an essential part of the IoT security. So a lot of this alliance, of course, has a number of big names like HP and Huawei and Dell and Microsoft and others. And what they have recommended is you need to provide a way to do local access to devices that helps with authentication of not only the devices but also the users and the technician. And what we have found time and again are that the passwords are just not effective for that kind of local access control. That is today's solution, and we all know how difficult it is to manage passwords. It's in fact virtually impossible to have high level of security, operational security, when access to devices is protected by passwords. Different technicians might need the same password. These passwords get shared by email. They could even be printed on the post-it note. And what results is a large backdoor and a security risk that is already exploited by hackers and governments. So secure access, secure device access during commissioning and other times when network connectivity is an issue, like retuning or recommissioning, becomes important. And this is a way in which you essentially extend your policy-based authorization to devices that are either outside your security perimeter or just cannot be accessed. And this methodology is now getting quickly standardized inside the IETF, which ARM is part of. So you can think of a scenario where a technician, an elevator is broken down and a technician comes into the building, or a lighting module needs to be replaced and there is no connectivity, and the technician is able to use their work password and email, so you don't need unsecure passwords anymore. And he's provided in one-time or a one-time authentication or a authentication that has an expiry time and date, so it cannot be repurposed later on. And you can even have fine-grained permissions for these access controls. For example, some technicians might be allowed access to a certain number of devices, but not others, whereas other technicians could have access to other groups which are either overlapping with the first group or not. So these are ways in which this secure access has been done. But ultimately, these are all mechanisms, all really ingredients to building a robust, secure system, which is what we started off with. There is a huge potential in smart buildings. That potential has been recognized by not only empirical data, but also a lot of analyst reports in which people have been looking at making their buildings, especially their people and assets, more valuable, productive, safe, and secure. But a lot of times, and lighting especially becomes an important backbone for all that data. But the progress has been held because of concerns in security. And today's webinar was really our way of showing what we as an industry, as an ecosystem can do in making sure that each and every IoT device that you put in, from the smallest of sensors to a lighting controller to a switch to a Linux gateway box, is secure, starting from the foundation, starting from the device level, going upwards to the communication level and up to the cloud.